Hello, data structure students. Hope you're all doing well. After our first real programming assignment, we got a lot of questions about a lot of basic C++ stuff. So here's what I'm going to do. I want us to go over some slides. This is completely supplemental. You don't have to do it. It's just out there for those of you who think you might need a little extra help. So a few extra slides from a class that I used to teach on coding in C and C++. So, a lot of this you've already seen, so I'm going to hit some of this somewhat briefly, and then a few things I'm seeing people struggle with, I'm going to go into a little more deeply. But the first thing, let's talk a little bit about output. Pretty much the whole purpose of the first sort of dry run program that we did for the class. So when I did this class last, I did a little bit of statistics. Yeah, so, up here we got people understanding the syllabus lecture, but that's not important for today. And the subjective programming experience that people coming to the class had. On a scale of 1 to 5, most people felt like they fell right here. Second largest group, sort of middle of the road. And, a couple folks think they're hot stuff, which you might be. I don't know. But when things start, when the rubber hits the road, usually this curve sort of normals out and looks a lot like this. So the bulk of the students probably fall really right here towards the middle. And, I don't think this is probably going to be too different than our class. Probably a lot of different programming language experience, a lot of Java, a lot of C. Here we're probably going to see a lot more Python just because that's used in the intro classes. But if you've had experience with any of these C-like languages, and really Java too, most of what you're going to see here is going to make a lot of sense to you. Okay. The important thing is that being a good programmer is about writing clear instructions. Especially when you first start programming, a lot of this feels like voodoo. It feels like absolute magic. Like why does typing one line of code do something and typing a line of code do something else? And get away from that feeling of it's magic. Start understanding that it's actually an instruction, like a very specific instruction, and you have to understand what the instruction's doing in order to understand what your program's doing. Now, the horrible thing is that computers are so freaking dumb. They're going to do exactly what you tell them to do, no matter how well-informed or uninformed that decision might be. And especially C and C++, those languages assume that you really know, that you're telling it to access a pointer here versus a pointer there or something like that. So, as horrible as it is, when your program crashes, it's just doing exactly what you told it to do. It has no consciousness whatsoever. So you've got to think ahead and take into account all the places your program could go wrong. I always like this one, the way you write something is very important. Same with English language, same with most programming languages. At this point, in the classroom, I'd have people write down instructions for like doing peanut butter and jelly, and making a sandwich. And you get some really humorous things, but really, if you literally did the exact steps that it took to make a peanut butter and jelly sandwich, you'd probably have dozens and dozens of steps. While, most people, when they think about it and sort of intuitively write it down, they'll write it down maybe half a dozen steps. But you've got to do everything specifically. You've got to open the bag of bread, you've got to open the peanut butter, you've got to open the jelly. And there's sub-steps in here, like, unscrewing the lid and so on and so forth. So really, you've got to hit each one of those steps in extreme detail. And that's how writing your program is supposed to be. If it feels like you're having to write too many things to make something happen, chances are you're writing the exact amount needed to make the thing happen. Because programming is all about writing way too many instructions. So a general anatomy of a C++ program, usually you're going to want to have a comment at the top of your program. This is where you write your name, the date you last edited the program, description of what it's about, if it's for a class, what class is it for, and those kind of things. Also important for this class and your other classes, if you cited any material from outside sources like notebook, like textbooks or tutorials, go ahead and cite those guys inside of your comment at the top. You'll sometimes hear this referred to as a header block. Some of you had not heard this comment before, or heard someone call this portion right here a header block. If you hear someone talking about the header block of their code, this is what they're talking about. That big comment block at the top of your code where you say what your program is going to be doing. The next thing are these guys. Usually at the top you're going to have hashtag include something. These are technically called directives, but honestly most programmers just call them includes. All of your programs will have a main function and something happening inside of that main function. In this case, we're just writing hello world. And std : cout is just the standard output. So outputting this text to your terminal. And std : endl is an inline character. So it makes essentially prints a new line and technically does something called flushing your output buffer, and makes whatever is currently waiting to be displayed on your screen. Now your main function is a function, and all functions have to have some sort of return type. Technically, your main should always return an int. So most of the time, your main is just going to return 0. Usually you return positive numbers if something went right, if you want to tell the exit status of your program to something else that might have run it, and negative numbers if things go wrong. But the vast majority of the time, you're just going to do return 0. Now, one thing you will see is this right here, using namespace std. What that does, that lets you use things in this namespace in shortcut. So we can actually just do cout and endl, which is probably what you're most used to seeing, as opposed to writing standard cout and standard endl. So in C, the standard way of printing formatted output is printf. In C++, it is cout. These guys work effectively the same way. There are differences, we'll say. Some of which technical, some of which practical, but you can sort of think of them as the same. Now the reason I want to show you both of these is, especially if you go out and start being a programmer in the wild, you're going to see that there's going to be people mixing standard C and standard C++ function calls, because all of C is actually part of the C++ standard. And so, yeah, these guys behave effectively the same way between these two. So they let your computer communicate with you. They're means of providing output. Okay, and so, printf, if you want to print hello world, you do printf, and then prints for your function parameters, and then in a string the thing that you wanted to output. Now, this part you guys probably are already well aware of, white space. So I'm not going to spend a whole lot of time talking about white space, like new lines, tabs, spaces. Usually I have to reference these using escape sequences, which are special character combinations preceded by this slash. Like /n gives you a new line, /n gives us a tab. There's no escape sequence for a space, you just hit the space bar. Now, certain special characters need their own escapes. For instance, since we use the slash to escape other sequences, it itself is a reserved character. So in order to do a backslash, you actually have to do \\. And this is true for both using printf and cout. So, some examples of what these guys look like if you outputted them. And, now you can sort of see what this would look like formatted for cout. But frankly, if you've made it this far, you've probably figured this out. So you can't mix these guys together. So you got to use an escape sequence for those. And some more examples of using those escape sequences. Now, what you can do, you can go home and try to implement these guys here. So beam me, big space here, up Scotty. The president says, hi there, in quotes, and /n is a new line in C and C++. So you're going to have to do a special escape here to actually display the escape sequence. So kind of neat. Okay, we're going to wrap up the output examples right here. And if you guys have any questions, be sure to let me know. I'm not going to support these lectures too much because they're not actually part of the data structures class, but I'm putting them here to help you get a little bit ahead if you need that. Okay, so see you folks in the classroom.